Good morning, students. So today I'm going to explain you a very fundamental and basic chapter of chemistry, which is called chemical bonding. Now we are very much familiar with the word bonding in chemistry, but if we have to deep dive into the concept, uh, we need to know about certain theories which came by time to time as scientists discover and understood the interaction between the molecules and the atoms better. So, starting from, let's understand what chemical bonding actually is. Now, we know in chemistry that molecules are formed by atoms, and those atoms are bonded with certain kinds of bonds in which some electrons are involved. Now, we have some ideas about how the what the structure of atom is. Now, as from our earliest certain studies, we are much familiar that an atom has a core nucleus which is positively charged, and electrons move around it in certain shells called orbitals around the nucleus, and most of the atom is empty. Now, if we talk about bonds, electrons are the major contribution in it. Like the bonds are majorly formed by the sharing or donation or accepting of electrons. Now, talking about bonding, there are certain kinds of bond. The first, let's study about ionic bonding. And secondly, we will also study about covalent bonding. Now, talking about ionic bonding, when there will be a donation or acceptance of electrons between the atoms and the bond which will be formed, it is called ionic bond. And in terms of covalent bond, when there will be sharing of electrons between two atoms and the electrons will be not located particularly on one atom, but it is shared between both the atoms. Such kind of bond is called covalent bond. Now, what is the driving force between for forming a bond? Now we go through why the bonding is formed. We have gone through what kind of bonds are there. Now we will see why the bond is required. Now it is in nature that the system always tends to lower its energy, right? So when atoms are in free state, it has higher energy than atoms when they are bonded and forming molecules. They lower its energy. That's why nature favors to form bonds, and what kind of bond it will form, that will depend on certain rules. Now scientists have studied various types of and given various types of theories, and one of the first theory which was able to explain what kind of bonding molecules have was Lewis theory. Now, this theory is based upon the noble gases. Now, we are very much familiar with the nature of the noble gases as they are non-reactive. They are not. They don't react with any other kind of atoms easily, any other elements, and they are mostly remain in their elemental state, like helium, argon, xenon, krypton. These are called noble gases because they stay inert in most of the condition. They are majorly used also, like example argon gas is used in certain reactions also to provide a inert environment because it is very non-reactive. Why it is non-reactive? So there is reason. It is non-reactive because of its, so it has a particular kind of a structure which which gives its inertness to it. Scientists have studied that made a theory that an atom is kind of a cube. Cube has 8 corners, so they have come across a rule called the octet rule. According to this rule, an atom tends to occupy an atom the electrons tend to occupy all the 8 corners of the cube. When the cube is incomplete, when each corner of the cube is completed by the electron, it is called an noble gas configuration. And when an atom's or by forming a molecule attains those stable configuration, it becomes more stable. So as low as Lewis studied, it is based on the noble gases that every bond tends to complete its octet. Now we studied about different kind of bonding, which is ionic bond and covalent bond. Now in terms of ionic bond, let's take an example of NaCl. Now NaCl is an ionic compound, and the force of attraction is called the electrostatic force of attraction. Why? We are very much familiar with electrostatic force of attraction. When there is a positive charge and there is a negative charge, they will attract each other. Now in terms of sodium, let's talk about its electronic configuration. Now, let's first for study about a very basic concept which is called the valence shell. Now, what is a valence shell? An atom has a core, right? It's at the center, it has a nucleus and has electrons in different types of shells. Now, the outermost shell in which the electrons are present, that shell is called the valence shell, and that shell is majorly responsible for forming the bonds. So, the shell which is majorly responsible for forming an interaction with different atoms, that is called valence shell. So, if we look on the valence shell of sodium, it has only one electron. So we can represent. Now let's put some brief introduction to the how Lewis structures are. Lewis representation of symbols are made. First, we write the elemental symbol and we represent electrons by dots. So if a sodium has one electron in its valence shell, and let's talk about chlorine. Now chlorine has 7 electrons in its valence shell. So we can write 1, 2, 3, 4, 5, 6 and 7. So we can see that chlorine has 1 electron less to complete its octet, and sodium has 1 electron extra. So what does sodium and chlorine do? That sodium donates its 1 electron to chlorine, and chlorine completes its octet and attains a negative charge. So whenever an electron is we can represent electrons of different atoms by different symbols. So let's give a star to the electron of let's give the symbol star for the electron of the sodium, and dots for the electrons of the chlorine. So we can see that chlorine has 7 electrons, only 1 electron less to complete its octet, and sodium has 1 electron extra to complete its octet. So what does happen? That this electron goes over here and completes the octet of the chlorine and thus forms the ionic bond. Now, this was the example for ionic bond. Now, if we uh, talk about covalent bonding, when there will be sharing of electrons, so let's understand with an example of water. So, water has formula H2O with oxygen having 6 electrons. 1, 2, 3, 4, 5 and 6. Now it has 2 electrons less to complete its octet. And we know that hydrogen has 1 electron in its outermost shell. So we can represent like this. Now, if we know that covalent bonds are formed by the sharing of electrons. So, when this electron is shared with the another pair of electron of the oxygen, we can see it forms a bond. So, if we can represent atoms like this of hydrogen, and if we have to use some other color, we can use the yellow color for the oxygen. Let's keep the electron over here so we can make into one. Now we can see that oxygen has about 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And hydrogen has 2 electrons in its octet. Now this hydrogen has also a complete octet. because we know that Lewis theory is derived from the stability of the noble gases. Now, if we look at the valence shell or the outermost shell of helium, we see that it has only two electrons. So, the hydrogen, which had one electron earlier, completes its valence shell by the sharing of electron with oxygen and completed its shell. And in terms of oxygen, oxygen sharing its one electron with another electron of hydrogen, it completed its octet by 8 electrons. So this was the example of covalent bond in H2O. Now these are called the Lewis symbols, and this type of and Lewis explained the bonding in different kinds of compounds as per the octet rule of certain compounds. Now, every theory has its limitations. So, octet rule also had some limitations, like it was not able to explain the geometry of the molecules. For example, the molecule of CO2. This is the molecule of H2O. Now, both the molecules have three atoms involved, but the CO2 has a linear structure like this, but an H2O has a bent structure like this. Lewis failed to explain the geometry and certain other things like the magnetic behavior, the different kind of geometry shapes of the molecules which are formed. Now, to overcome these limitations, certain other theories were also developed. One such theory is called the VSEPR theory. It's called the valence shell electron pair repulsion theory. Now, Now, as this name indicates, it's called valence shell electron pair repulsion, which means there will be repulsion between the electrons of the valence shell. Now we are familiar that and what is the valence shell? Valence shell has the electrons which are involved in the bonding. Now, as per this rule, we know that there are electrons which are non-bonding. For example, in terms of H2O, we see that in H2O, the oxygen has only two electrons which are shared by the hydrogen, and two other electron pairs are called lone pairs. They are not involved in the bonding of the molecule. So, these electron pairs are called the lone pairs. So, as per VSEPI theory, the lone pair repulsion is the highest because it is centered on one particular atom, and as we know, when atoms bond to form molecules, the bonding electrons has lower energy. That's why the lone pair interaction energy is the highest, then the lone pair and the bond pair energy, then the bond pair energy. So, if we look on the structure, so as per this theory, we have the concept of steric number. Now, steric number can be given by number of lone pairs plus number of side atoms. For example, for steric number 2, in example of, let's take example of CO2, where steric number will be number of lone pairs. So how many lone pairs are there in CO2 on the center atom? So carbon is the center atom. So we know that carbon has no lone pair, so it has 0 lone pair, plus it has two side atoms which are oxygen. So its geometry will be linear. But in terms of H2O, where the steric number will be, for lone pair there will be two lone pairs on oxygen, plus there will be two side atoms, so 2. So it will have a bent structure. Let's take example of CH4. Now the steric number for CH4 will be, for number of lone pairs on carbon will be 0 and number of side atoms will be 4. So it will have a tetrahedral structure. Similarly, if we take example of pH3, it has steric number 0 plus side atoms 3. So it will have a trigonal planar structure. Now, VSCPR theory is based on the interaction of lone pair and bond pairs. Although it explains the geometry of the molecules, it somewhat fails to explain the magnetic behavior of the molecules and also the dipole moment, the formal charge on the molecules, which were discovered later. So, to overcome this theory, there was another theory which was post-advanced, was given and it was named as valence bond theory. Now, valence bond theory, which is also called VBT, now it uses an important concept of hybridization. Now, what is hybridization? Now, hybridization is the phenomena in which the the orbitals of the same energy overlap with each other to form hybrid orbitals. Now, it has certain postulates that the same number of when the same number of orbitals forming are involved, the same number of hybrid orbitals will be formed. For example, let's understand the bonding between H2. Now, 1s orbital of hydrogen with 1s orbital of another hydrogen will combine to form an molecule of H2O. In the same way, an 1s s orbital of any molecule can combine with an pz orbital of another of the same for example, some different atom which has p orbitals to give an sp hybridization, which will have a linear structure. In the same way, an s can combine with two p orbitals to give sp2 hybridization, which will have a trigonal planar structure. In a similar way, 3s, 1s and 3p orbitals can combine to give sp3 hybridization, which will have a tetrahedral structure. In similar pattern, an s, 3p and 1d orbital can combine to give sp3d hybridization to give trigonal bipyramidal geometry. Now, the concept of hybridization involves this combination of different orbitals to form hybrid orbitals of equal energy to form bonds. Now, moving further, hybridization was not able to explain the magnetic behavior of the molecules which has. So, to overcome this theory, there was development of another theory which was called the molecular orbital theory. Now, according to this theory, the atoms which has the orbitals combine to form molecules, then the molecules will have its own orbitals, which are called the molecular orbitals. So, the nature of the atomic orbitals will be completely vanished, and there will be formation of new orbitals which were called molecular orbitals. So, for example, uh, the 1s orbital of a hydrogen will combine with the 1s orbital of another hydrogen to form 1 sigma and 1 sigma star. So this here has 1 electron, this has another electron, and it will form bond. These are called the molecular orbitals, which is the stable one with a linear combination, symmetric combination of the orbitals, and this will be unsymmetrical combination of orbitals, which will give an unfavored, and when these electrons will be given energy, this will excite to go to the unsymmetrical orbitals, which would be the higher or excited state concept, which we can study in the higher lectures. So this was the concept of molecular orbital theory, in which is also called the MOT, where the atomic orbitals combine to form the molecular orbitals. Atomic orbitals will combine to form the molecular orbitals. Now, if the indicate the n is the number of electrons involved in a molecule, so when there will be n, which will be number of electrons less than 14 or equal to 14, and when there will be number of electrons greater than 14, there will be different kind of molecular orbitals formation. So for less than 14, we will have 1s, 1 sigma, 1 sigma star. Then this will be 2s, it will be 2 sigma, and this will be 2 sigma star. And afterwards it will have pi, pi. These are the three p orbitals, which are px, py, and pz, which are the molecule. And this is for another one, and this will be sigma, and this will be pi. Now for n number of electrons which are greater than number of electrons of greater than 14, we will follow this kind of a molecular orbitals. This is the 2s, this will also be 2s, the 1s, this will be 1s. So it will form 1 sigma, this is 1 sigma star, this will be 2 sigma, this will be 2 sigma star, this will be pz, or this will be sigma, these are pi, these are pi star, and this is also again sigma star. So this is about molecular orbital theory. Now, as per this theory, it was able to explain the magnetic behavior. So when there will be lone pair of electrons present in the molecular orbitals, there will be when the number of lone pairs is not equal to 0, we will have paramagnetic behavior. And when the number of electrons will be equal to 0, we will have diamagnetic behavior. which means it will have interaction with the magnetic field. So that's how molecular orbital theory explains the magnetic behavior of the molecules formed. So this was a brief introduction to various theories given by the scientists how the chemical bonding of molecules happen. Thank you. Oh, yes, start.